So you've been working with linear and exponential equations for a little while now, and you might have noticed that sometimes they're a little hard to work with. And so what mathematicians did is they came up with a new way of writing things called a function. And it's important to understand what a function is. So we'll talk about what is a function, how to write functions, and what's not a function. So first, let's consider an example. So here I've written an equation in the way that you're used to. It's a linear equation in y equals mx plus b format, y equals 3x minus 2, and I've sketched the graph over here. And that works really well with the non-function type of notation that you're used to. But now let's add something else in. And now we have another equation, y equals negative x minus 2, and I've added that in as well. But now you can see that it's starting to get a little bit confusing because here we have two statements of y equals, and it's maybe hard to figure out, well, which one are we talking about when we are talking about y? And we also need to figure out which graph is which, and we're calling them both equations that are y equals, so it would be easy to get mixed up. So let's start to use some function notation. So now I've rewritten each one of these equations in function notation form. Okay, so instead of y equals 3x minus 2, I have this f and then in parentheses x equals 3x minus 2, and then I have this g in parentheses x equals negative x minus 2. Now at first this is probably going to seem a little bit confusing, but once you get used to it, you'll realize, wow, this actually makes things a lot clearer. So first, how do we write a function and how do we say it? So we write it like this, with the name of the function is denoted by a letter here. It's f, and if there's a different function, you need a different letter, like g. Usually people use, when they're only working with one function, they use f. So you'll be using f most of the time. Now, this is a function of x, meaning that we're going to put a number in for x, and we're going to get the result, the output, and that will be the value of f of x. That might sound confusing, but it's just the exact same thing as you're used to up here. You would put a value in for x, and you would get an output. X is your input, y is your output, and that's how you would graph a line and understand and build a table of values and all that. Same thing here. It's just that now we say that it's a function. And we say, the way we read this is we say f of x equals 3x minus 2. G of x equals negative x minus 2. And when we make a table of values, we also write f of x and g of x instead of x and y. So for instance, when the table of values for that first function might look something like this. X is our input, f of x is our output, and we could put in, for instance, 0, and then we would get negative 2, and we could put in 1 and 1, and we could keep going with our table of values. Now, why is this useful? Well, for one thing, now we don't get mixed up with two y statements. We can have an f statement, an f of x statement, and a g of x statement. So it avoids some confusion. Another thing that it does is it gives us the ability to talk about what the value of the function is at certain inputs without having to write so much out. So for instance, before, if we wanted to know what y equals when x equals 4, well, we'd have to just say y equals, let's see, that would be 10. Y equals 10 when x equals 4. That's a lot to write out. Instead, what we can do is we can say f of 4 equals 10. And what this means to us is when x equals 4, so here we usually say f of x, but now we're putting a value in for x, then that equals 10. So it's a really short, easy way to say what the value of an equation, or in this case a function, is when the input value is a certain amount. And so those are two good reasons why we use function notation. And this is how we write the functions when it's just general or when there's a specific input value. Now let's talk about What's not a function? So one of the key things you need to know about functions is a rule. With functions, each input, usually that's an x value, can only have one output. So for instance, if you have 3 for x, you can't put it into the function one time and get 12 and another time get -2. It always has to be the same number. Now let's look at some examples. Here are two tables that both show an x input and a y output. Only one of them is a function though. Can you tell which one? Well, let's take a look. Here we have different x inputs, 0, 2, 4, 2. Oh, we have 2 times where the number 2 shows up. Once we get an output of 7, and the other time we get an output of 3. So this is not a function. So let's go ahead and say, no, this is not a function. There. The other one is a function because it doesn't repeat any of the x inputs, so we don't have any different outputs for the same input. Now let's take a look at some sets of points. Here are 2 sets of points. Now when we say points, we mean coordinate pairs, like this one is x equals -2, y equals 3, x equals 4, y equals 9, etc. One of these is a function, and the other one isn't. Can you tell which is which? Right. Well, you can spot that in this set of coordinate pairs here, we have 4 as an input and 9 as an output, and then 4 as an input and 7 as an output. So same input, different output. So in this case also, this one is not a function. The one above, however, is a function. Now let's take a look at the easiest way to tell if something is a function, and that's a graph. Which one of these 2 graphs is a function, and which one isn't? Well, remember, a function has to have only one output for the input of x. And one way to do that is just to go along here and say, okay, if x is this, well, here's our output there. If x is here, output there. In other words, if you could draw a line up and down, if it only crosses the function once, then that's the output, only one output. But over here, let's say when x equals 5, look, it has this output and this output down here. So if we were to draw a vertical line, we would cross the function's graph twice. And so what that means is that this one is not a function. So what have we learned? Well, we know what a function is and some of the reasons why we use function notation. We know how to write and say functions now, and we've learned what's not a function. So now you're prepared to start using this function notation. Again, it'll be a little confusing at first, but once you get used to it, you'll realize that it really saves you time.